In exercise 1.3.3, we look for the minimal and the maximal premium when the utility function is given by this exponential utility. So we start with the minimal premium P minus, which is the premium the insurance company wants to receive in exchange for insuring the risk X. So in case the insurance company insures the risk, the expected utility is given by the utility applied in W, the initial wealth of the insurance company, plus P minus, because the insurance company receives the premium, minus X, because the insurance company is paying for the risk X. So this expected utility is a utility for the insurance company after insuring the risk. This expected utility should be equal to UW, which is the utility of the insurance company when there is no insurance policy. So if we now fill in the exponential utility function, we get the following. We get that the expected utility is minus alpha e to the power minus alpha applied in W plus P minus minus X. And on the other side, we have minus alpha e to the power minus alpha in W. Then we see that this minus alpha here cancels with this minus alpha. And if you look in this expectation on the left hand side, we can take out of the expectation the term e to the power minus alpha W plus P minus, which is a non-random term. And then inside the expectation I have e to the power alpha X, and this should be equal to e to the power minus alpha W. Then again you see that this term cancels with this part here, which means that what is left is e to the power alpha P minus the expectation of e to the power alpha X, which is equal to 1. And if you then solve for P minus, you get that P minus is equal to 1 over alpha, the logarithm of the expectation of e to the power alpha X. And then we call that this here, this expectation e to the power alpha X, is the moment generating function m of the random variable X in alpha, which proves the result for the minimal premium. We can now determine the maximal premium P plus, which is the premium the insured is willing to pay in exchange for insurance for the risk X. So in case the insured is not insuring his or her risk, the expected utility is the following. It's the expectation of U. The W is now the wealth of the insured, and you subtract the risk X because you do not take any insurance. So this expected utility is the expected utility when there is no insurance. And this should be equal to the utility in case you take insurance. If you take insurance, your utility, it's U applied in, you have your initial wealth, and from your initial wealth you pay the premium P plus. But once you pay the premium, you don't have to pay for the risk X anymore. So the right hand side is a utility when you take insurance. Alright, so we have to solve this equation in case we have exponential utility function. So we fill in the exponential utility function instead of the U. So then you get minus alpha e to the power minus alpha W minus X. And on the other side you get minus alpha e to the power minus alpha W minus P plus. And then we see that this minus alpha cancels with this one. So you get the expectation e to the power minus alpha W minus X is equal to e to the power minus alpha W minus P plus. And then you see that this term alpha W e to the power minus alpha W cancels with this part here. So what you end up with is here e to the power alpha X, and on the other side you have e to the power alpha P plus. And then if you take the log on both sides and you divide by alpha, you find that P plus is also equal to 1 over alpha, the log of the expectation e to the power alpha X. And then similar to the case where we had the minimal premium, this expectation here is the moment generating function m of the random variable X in alpha, which proves the result.